Well, welcome back to online math class. We are going to continue talking about probability, and this time we're going to make it a tiny bit more complicated. We're going to talk about compound probability. So before we just looked at the probability of simple events like rolling one die or flipping one coin. So we're going to double our fun today, and we're going to look at the probability of compound events, which is more than one event happening at once, like rolling two dice or flipping a coin and rolling a dice, things like that. So we're going to start with a little video.
Going to your town's summer carnival every year for as far back as you can remember. This year, you're bringing your kid sister along. Your little sister really loves ducks, so she gets pretty excited when she sees the Lucky Duck game. The thing is, she also loves monkeys, so she has her heart set on winning the big prize. To win the giant monkey, you need to match two ducks that have the number 1 written underneath them. It really all depends on chance, but your sister is not going anywhere without that monkey. There are 6 pairs of ducks numbered 1 to 6, 2 with the number 1, 2 with the number 2, and so on. Can you figure out the probability of your sister matching the 2 ducks and winning the giant monkey? Let's hope she doesn't run out of pocket money before the monkey is hers. In this lesson, you'll learn how to find the probability of a compound event like this one.
All right, so that's what we're going to look at, compound events. What are the chances of little sister winning that sock monkey? So go ahead and hit pause and add a new entry to your notebook or make it happen on a piece of binder paper. So the title is Compound Probability, and our essential question is, how do you find the probability of a compound event? Okay, so a compound event, like I said before, includes 2 or more simple events. And the thing is, some of them can be easy, like rolling 2 dice, or even flipping 2 coins, but even that, like trying to keep track of everything, is going to be complicated. So this is going to be a 2-part lesson. There's going to be 2 different videos. It's going to be 1 set of notes though. And in this video, we're going to focus on ways to stay organized and keep track of all the different things that can happen. All right, so go ahead and add these things to your notes. Hit pause and write them down. A compound event includes 2 or more simple events happening at once. Like the examples I said, rolling a dice and flipping a coin, or rolling 2 dice at once, 3 dice at once. So make sure you have these definitions and examples in your notebook. All right, so you're going to watch me do this example. Jacob rolls 2 dice. And this is a sum table here. So it's kind of like if you're playing Monopoly or something, and you roll 2 dice and you add them together and you move that many spaces on the board. He needs to roll an 8 to win. If he gets a 7, he lands on his sister's hotel on Boardwalk, and he's done. He needs to get to start or to go and get those $200, All right, so he needs to roll an 8 to win. What's the probability that he's going to win on the next roll, or maybe even just stay alive? Okay, so this is one method of keeping organized. It's called a table. So you can roll a 1 and a 1, and that would add up to 2. A 1 and a 2, which would add up to 3, a 1 and a 3, 1 and a 4, and so on. I'm going to go ahead and hit pause and fill this out. All right, so this is all the things that can happen when he rolls 2 dice and add them together. So step 2 says, how many possible outcomes are there? Well, I can count them all, 1, 2, 3, 4, 5, 6, and so on, but I have 6 rows of 6, which gives me 36 possible things that can happen. Notice some of them end up being the same, but they are different events, okay? So, like, I can get a 4 by rolling a 1 and a 3, and I can also get a 4 by rolling a 2 and a 2, but those are considered different outcomes. All right, so then it says, circle all the outcomes that give me a sum of 8. It works out that they end up being in this little row right here. And how many ways are there getting an 8? There are 5 different ways of getting an 8. And since there's 36 possible outcomes, that means I have a 5 in 36 chance, or Jacob has a 5 in 36 chance of getting an 8 on his next roll. Okay, grab your whiteboard or your scratch paper or whatever, and I want you to try these 2 problems here. Give me an example of an event that is more likely than rolling a sum of 8, and an example of an event that is less likely than rolling a sum of 8. So go ahead and hit pause, try it out, and we'll come back together. All right, what has more outcomes on there than 8? The only thing there is 7. There are 6 ways of getting a 7. So that's 6 out of 36 or a 1 in 6 chance. For events that are less likely, well, we know it's not 7 because that's more likely. 6 is a tie. There's 5 ways of getting 6. And so pretty much everything else. So there's 4 ways of getting a 5, 3 ways of getting a 4, 2 ways of getting a 3, and only 1 way of getting a 2. And then we have these guys over here. So if you said 2, 3, 4, 5, 9, 10, 11, or 12, you are correct. You did not need to have all of them, by the way. Okay, so that was the table method. So that's where we put the outcomes on the top and side of the table and we fill in the outcome. So go ahead and hit pause and add this definition to your notes. Okay, here's another method of keeping organized. So we have a Scooby-Doo sandwich over here. It says a deli prepares sandwiches with 1 type of bread, white or wheat, 1 type of meat, ham, turkey, or chicken, and 1 type of cheese, cheddar or Swiss. Each combination is equally likely. So if you like walk in there and you're like, surprise me, what is the probability of choosing a sandwich at random and getting turkey and Swiss on wheat? So this is the this is the tree method. So you can kind of like turn your head sideways, and this is like the trunk of the tree, and here's the branches and the leaves. It's kind of like a sideways tree situation. So sometimes they go sideways, sometimes they're upside down, but they're called a tree method. And you have layers. So we have a bread layer, white or wheat. We have a meat layer, ham, turkey, chicken. We have a cheese layer, cheddar or Swiss. And you can follow it and see the combinations. So white, ham, cheddar, white, ham, Swiss. White, turkey, cheddar, white, turkey, Swiss. White, chicken, cheddar, white, chicken, Swiss, and so on and so on. So the question was, what was the likelihood of getting turkey and Swiss on wheat? So we have wheat, turkey, Swiss. That is one option out of how many possible sandwiches are there? You count the ends of the branches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 possibilities. So you have a 1 in 12 chance of getting a turkey and Swiss on wheat. So go ahead and hit pause, grab your whiteboard or scratch paper, and I want you to try these 2 problems. Find the probability of getting a ham sandwich, and that could be any sandwich with ham on it. And find the probability of a sandwich containing Swiss. So hit pause, give it a try. All right, probability of getting a ham sandwich. We have white ham cheddar, white ham Swiss, wheat ham cheddar, wheat ham Swiss. So there are 4 different ham sandwiches out of 12 options altogether. So that gives us a 1/3 chance, or a 1 in 3 chance of getting a ham sandwich. Sandwich containing Swiss, well, we have 1, 2, 3, 4, 5, 6 sandwiches that have Swiss cheese on them out of 12 total, and that simplifies to 1/2. Okay, so again, that was a tree diagram. Hit pause and write this definition. Okay, we have one more type of organization method to learn about, and that's called the list method. So this says the combination for Kahim's locker is a 3-digit code that uses the numbers 1, 2, and 3. Any of these numbers may be repeated. Find the probability that Kahim's randomly assigned number is 222. All right. So you notice that this list is very organized. So it's not like 1, 3, 1, 2, 3, 3, 1, 1, 1. No, it goes 1, 1, 1, 1, 1, 2, 1, 1, 3, 1, 2, 1, 1, 2, 2, 1, 2, 3. So you notice only one thing is changed each time. Like these are all 1s in the first position, and then we have a 1, 2, 3 in the second position. So it's like very organized and orderly. And here's all the possible combinations of a 1, a 2, and a 3. So what is the probability of getting probability of 2, 2, 2? So we look and we see, okay, 2, 2, 2 is just one possible combination. Out of how many combinations? Well, each of these are 3. So 3, 6, 9, 12, 15, 18, 21, 24, 27. There's 27 different combinations that there could be, and having all 2s is 1 out of 27. So not really a very secure pin number situation here. So go ahead and hit pause and find the probability of having 1, 2, 3 as your combination. And then find the probability of having 2 3s in the combination. And those 3s could be anywhere, okay? But as long as there's 2 3s in the combination, like this one, for example, then that counts. So hit pause, make it happen. All right, let's see how you did. So the probability of getting 1, 2, 3 is your combo. There's only 1, 2, 3 out of 27 total, so the chances are 1 in 27. For this one, 2 3s in the combination. There's actually 7 different combinations with 2 3s in it. This one has 3 3s, so maybe you didn't count it. Okay, but it does have 2 3s, right? So if you didn't count that one, you would have gotten 6 out of 27, which simplifies to 2 ninths. Or if you did count that one, you get 7 out of 27. Either is fine. Okay, add this to your notes, the list method. Hit pause and write that down. Okay, so so far we've previewed all 3. Now we're going to do a little bit of extra practice with them, and then that'll be it for this lesson. All right, so it says Drake rolls 2 fair number cubes. We're going to complete the table to find the sample space for rolling a particular product on 2 number cubes. Product means times them together. So we're rolling the dice and we're timing them together. So 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, and so on. I'm going to help you out, and I'm going to hit pause and I'm going to fill this in, and then I'm going to ask you to answer the 2 questions. Look at that. Wasn't that nice of me? So I filled that out. It's like a times table. So what I want you to do is try these 2 questions on your scratch paper. What's the probability that the product of the 2 numbers Drake rolls is a multiple of 4? Remember, multiples of 4 are things like 4, 8, 12, 16, like anything that you can go 4 times and get. So go ahead and look at this, kind of count how many multiples of 4 are there, count how many total outcomes there are, and give me a probability. And then go ahead and try number 3 as well. So once you're done with that, unpause the video and check your answers. Hit pause, no cheating. All right, so let's take a look here and see what we got. So multiples of 4, I circled all of them. So of course they were the ones in the 4 rows, but hopefully you didn't let these guys sneak by you. And if you count them up, there's 15 out of 36 possible outcomes. Less than 13, so I kind of drew this blue line here. And everybody on this side is less than 13. All these are greater than 13. So if I add them all up, I find that there are 23 numbers out of 36 numbers that are less than 13. So hopefully you did well. Let's try another example here. So I want you to draw a tree for this one. Okay, so grab your whiteboard or your scratch paper and get ready to draw. So it says the power's out at Mark's house and he gets dressed in the dark. He chooses his clothes at random. He picks a shirt, white, blue, or gray. He picks pants, black or blue, and he picks a pair of shoes, checkered or red. So draw a tree diagram that represents all the possible choices. I'm going to get you kind of started on here. All right, we're going to do some layers to it. So I want you to make a shirt layer. I want you to make a pants layer. And I want you to make a shoes layer. And remember what a branching diagram ends up looking like. It's like the Scooby-Doo sandwich example. Let me go back to that one real quick. Oops. It's going to kind of look like this. See, there's a bread, meat, and cheese layer, and we've got all these branches. So I want you to do the same thing. And you can abbreviate. You don't have to write the colors all the way out. But grab that piece of paper and make yourself a diagram. And then when you're done making the diagram, I want you to try to calculate the probability. Okay, hit pause and give it a try. Okay, I want you just to check in on your tree diagram right now. I didn't answer these questions yet. Maybe you already did, and that's good. But before I go over these answers, I want you to check on your diagram. Okay, so it should go blue, black, checkered, blue, black, red, like that. I abbreviated on here because it gets a little messy. But, compare yours to mine, and it should look pretty similar. Like it should have a lot of things going on here. So before you calculate these, or even if you already did, count the ends to see how many outcomes there are before you get the probability here. All right, hit pause again. I'm going to calculate it, and then we can compare answers. All right, so how many of these outfits have red shoes? Well, if we count our branches here, we have 6 out of 12 possibilities with red shoes, which comes out to 1/2. And the probability that no item is blue, that means this whole piece right here, like we don't count that. So we can do white, black, checkered, white, black, red, gray, black, checkered, gray, black, red. Oh, geez. Gray, black. Yeah. Okay. You see what I mean, right? So if I count them up, there's 4 outfits total with no blue in them at all. That simplifies down to 1/3. Okay, last one, guys. So I want you to try the list method to list all the possible combinations of rolling 2 dice and adding them together. Okay, so we've done it before with the table. We're going to try it a little differently with the list method. So I got you started, okay? So you get a 1 and a 1 and get a 2, a 1 and a 2 and get a 3, a 1 and a 3 and get a 4. Stay organized, just do your list, and then you can check mine before we try these. Okay, so hit pause, make a list. Well, wasn't that fun, huh? But hey, we did it, and we got this whole hot mess over here. And if you did it correctly, your numbers should be increasing by 1 every time. And hopefully you stayed organized. So I had 1 in the first position, 2, 3, 4, and then I kept my second position numbers organized as well. I went 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and so on. And hopefully you know how to add all the way up to 12. Okay, so now go ahead and hit pause, and I want you to find the sum, probability of getting the sum of 7. That means any one that has an answer of 7, and probability of doubles. Doubles are like rolling 2 1s and 2 2s, etc. So hit pause, figure that out, and then check your answer against mine. All right, let's look and see how you did. So probability of getting a 7, I did that in red, so I found all my outcomes that equaled 7. There were 6 total out of 36 possible outcomes, and that simplifies to 1/6. And the probability of getting doubles, I boxed those in green. There's 6 ways of getting doubles out of 36, so again, we get 1/6. All right, well, you made it. That was just part 1, so just hold on to those notes. Don't text or email them to your teacher yet. There is a part 2 of this compound probability, and after you do that and you add those notes to these, then you're going to turn it in all at once. So I hope you enjoyed as much as possible learning about that, and hopefully it comes in handy next time you're playing Monopoly. Okay, see you next time in math class.